In this video, I will be discussing about variances, covariances, and correlations of special cases. Now take note that when the covariance value is positive, this indicates a direct or positive linear relationship, and we can also be sure that when you compute for the correlation coefficient, the value is also positive. However, when the covariance value is negative, this indicates an inverse or negative linear relationship. And when you compute for the correlation coefficient of this relationship, we can be sure that the R value is also negative. But when the covariance is 0, sometimes the correlation coefficient is also 0. And this indicates that there is no linear relationship between the two variables. And for the special cases wherein the correlation coefficient value is positive 1 or negative 1, this occurs only in the case of a perfect linear relationship where the data points lie exactly along a straight line, but this straight line is a non-vertical or non-horizontal line. Because if the data points fall on a vertical straight line or a horizontal straight line, then the correlation coefficients cannot be determined. And if the R value cannot be determined, this means that there is no relationship between the two variables. Now take for example the 6 students whose ages and the test scores are this one. We can compute for the mean for x sub 1 because the mean is equal to the summation of x sub 1 divided by n. And to get the summation, we just add these numbers here, which is the sum is 102. So 102 divided by 6 because there are 6 of them, and this is equal to 17. So you notice that all of the 6 students are having the same ages. So definitely the average is just 17. We can also find the average for the variable y because this is the summation of y sub 1 divided by n. So we need to add these 6 numbers, 80, 89, 85, 84, 82, and 90. And the sum is 510. So this is 510 divided by 6. And the quotient is 85, which means that their average test score is 85. Now we can compute also for the variance of the variable x sub 1. And the variance, we know it's the summation of the square deviations, the values of x sub 1 from its mean. And we divide this one by n minus 1. So to get this one, we need to subtract every value by its mean. So if you subtract 17 by the mean of 17, that's 0. So all of these are 0 because they are all 17ths. And then if you square 0, of course, you've got a square value of 0 here. And the sum is also 0. So this is 0 divided by 6 minus 1. And the variance is 0. So that means that the variance for the variable age, which is x sub 1, is 0. Because as you can see, the values are not varying from its mean. It's constant, so we understand that the variance is 0. We can also find the variance for the variable y sub 1 because this is the summation of y sub 1 from its mean quantity squared divided by n minus 1. So to get this one, we need to subtract every y from its mean. So 80 minus 85, that's negative 5. 89 minus 85, that's 4. 85 minus 85, that's 0. 84 minus 85, that is negative 1. And 82 minus 85, that is negative 3. And 90 minus 85, that is 5. And if you square these values, this is 25. And the square of 4 is 16. The square of 0 is 0. The square of negative 1 is 1. The square of negative 3 is 9. And the square of 5 is 25. So adding these 6 numbers here, we have the sum of 76. So this is equal to 76 divided by 6 minus 1, and this gives you a variance value of 15.2 here. Then, computing for its covariance between x sub 1 and y sub 1, we have the summation of the product of x sub 1 value, its deviation from its mean, times y sub 1, its deviation from its mean also, divided by n minus 1. So, to get this one, we need to multiply this column by this column here. So 0 times negative 5, 0. 0 times 4, 0. 0 times 0 is 0. 0 times negative 1, 0. And 0 times negative 3, 0. As well as the last one. So they are all zeros. And the sum is also 0. So this is 0 divided by 6 minus 1. And 0 divided by 6 minus 1 is also 0. So since the covariance is 0, meaning there is no linear relationship between the two variables here. But how about for the correlation between x sub 1 and y sub 1? The correlation coefficient is equal to the covariance, which is 0, divided by the standard deviation. So covariance between x sub 1 and y sub 1 divided by the standard deviation of the variable x sub 1 times the standard deviation of the variable y sub 1. We know that this numerator is 0, but we've got the standard deviation of the variable x sub 1, which is also 0. So 0 divided by 0 is indeterminate. So that means that we cannot determine its correlation coefficient. So there is no correlation here. Why? Because mathematically, we cannot compute its correlation coefficient. We cannot determine. Why? Because the x sub 1 variable is not varying, while the y sub 1 variable is varying. So the x sub 1 is constant while y sub 1 is varying. So therefore, there is no relationship that we can determine here because they did not co-vary. The meaning of covariance is that as one variable varies, there is a corresponding variation in the second variable. But here, our first variable is not varying. This means that the two variables are not co-varying each other here. So let's sketch the graph of this one. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 50 here. So we'll just write 5, 10, 20, 30, 40, 50 here. And we have 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90 here. So we have 80, 82, 84, 86, 88, and 90 here. Now let's plot the point. The first student here, the age is 17 and the score is 80. The second student, the age is 17 and the score is 89. So it's here. Third student, 17, but the score is 85 here. And then the fourth student is 17, but the score is 84. And then 82, because the age is constant, and then 90. Then you can see that all the points fall on a straight line, on a single straight line here. And what kind of straight line? It's a vertical line. So even if the points fall on a straight line, it does not guarantee that there is a relationship, because in this case, all the data points fall on a straight line, on a single straight line, but there is no relationship because one variable, in this case, the x sub 1, which is the age, is constant here. So it's not true that when your data points fall on a straight line, you have a perfect relationship. That's why here in my definition that positive 1 or negative 1 occurs only when the data points lie exactly along a non-vertical and non-horizontal line. So in this case, all the data points fall on a single line, but there is no perfect linear relationship. And there's not even a small relationship. Now let's proceed to the second example here, wherein the first variable is a social media time and the second variable is the number of subjects enrolled by the student. So the first student incurs 15 minutes social media time every day on average, but he enrolled 7 subjects. Second student, 30 minutes social media time, enrolled also 7 subjects. So we are trying to relate the social media time and the number of subjects enrolled in school. So let us compute for the mean of the variable x, and the mean is the summation of x sub 2 because our x sub 2 is the social media time. So adding these numbers, we have a sum of 168. So 168 divided by 6, and you've got a mean of 28 here. Also, we need to find the mean of the variable y sub 2, and the formula is the sum of all the values in y sub 2 divided by how many of them. So adding these 6 sevens here, we have 42 as the sum. So this is 42 divided by 6, and 42 divided by 6 is 7, and it's very obvious that the mean of all sevens is 7. Now let's compute for the variance of the variable x sub 2. Now the variance is equal to the sum of the square deviations of all the values of x sub 2 from its mean. And we divide this one by n minus 1 because we consider this value, these 6 subjects, as a sample of all the subjects. So to get that one, we need to subtract every x sub 2 by its mean of 28. So 50 minus 28, it's 22. 30 minus 28, it's 2. 25 minus 28, that's negative 3. 11 minus 28, that's negative 17. And 45 minus 28, that's positive 17. And 7 minus 28, that's negative 21. And squaring 22, we have 484. The square of 2 is 4. The square of negative 3 is 9. The square of negative 17, it's 289. The same with the positive 17 because the square of positive or negative are all positive. And the square of negative 21 is 441. Now adding these 6 numbers, we have a sum of 1,516. So this is 1,516 divided by 6 minus 1. And the variance is equal to 303.2. So this is the variance of the variable x sub 2 here. Now let's proceed for the variance of the variable y sub 2. So variance of y sub 2, which is equal to the summation of the squared distances of the values of y sub 2 from its mean. And we divide again this one by n minus 1. So our variance of the variable y sub 2 can be obtained if we subtract our y sub 2 by its mean, which is 7. So 7 minus 7, 0. 7 minus 7, 0. So all of these are zeros because these are all 7s, and subtracted by its mean by 7, the difference is 0. And the square of 0 is also 0. And the sum of all these zeros is 0. So the numerator here is 0 divided by 6 minus 1. So the variance of the variable y sub 2 is 0. And that is very understandable because the values of y sub 2 are not varying. It's constant. Now, let's compute for its covariance. The covariance of x sub 2 and y sub 2. This is equal to the summation of x sub 2 minus x sub 2 mean times y sub 2 minus its mean. And this can be obtained by multiplying this column and this column here. So 22 times 0 is 0. 2 times 0 is 0. Also this one. So all are zeros here. because one of the factors are 0. So the sum is 0, and this will be divided by n minus 1. So this is 0 over 6 minus 1, and the covariance is 0. And this indicates that the two variables don't have any relationship, because as x sub 2 varies, y sub 2 is not varying because it's constant. Now let's compute and see what's the correlation coefficient between x sub 2 and y sub 2 here. The correlation coefficient is the covariance between the two variables divided by its standard deviation values here. The standard deviation of x sub 2 times the standard deviation of the variable y sub 2. And since the covariance is 0, so the numerator is 0, but one of its standard deviation is 0. Which one? The standard deviation of y sub 2. Because standard deviation, we know, it's the square root of the variance. And since the variance is 0, its standard deviation is also 0. So 0 times a non-zero is 0. So we have a denominator of 0 and the numerator of 0. So here, we don't have any correlation. No correlation. Why? Because the correlation cannot be determined. Why we cannot determine the correlation? Because one variable is constant. So when you plot these two variables in a scatter plot and you use your social media time as your x-axis here, and your number of subjects enrolled is your y variable, then when your social media time is 50, the number of subjects enrolled is 7. And when your social media time is 30, 7. The third student, 25 minutes social media time, number of subjects enrolled, 7. 11, it's also 7. And then 45, it's also 7. And then 7 is also 7 here. And you notice that all the data points fall on a single line, single straight line here. So even if the data points fall on a single straight line, but when the straight line is a horizontal line, the two variables are not related to each other because one is constant, the y, the number of subjects enrolled. So no matter what time you spent in social media, it does not co-vary with the number of subjects enrolled because the number of subjects here is constant. So these are the two examples wherein the correlation coefficient cannot be determined. So there is no correlation. That means the two variables are not related to each other. So if it's constant, the variance is 0, therefore the covariance is 0, and hence the correlation coefficient cannot be determined. So there is no relationship between the two variables. And I think this is a good place to stop. If you learned something today, please check out my channel for more videos like this and click subscribe. Click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.